Welcome back, learners. As you know, in the previous video, I was discussing with you regarding how to prepare the column positions as well as the beam positions in the AutoCAD drawing. So I clearly wanted to make you one thing clear, that whatever the column positions we have done initially as well as the beam positions we have done initially based on the plan given by the architect is not final. It is just a preliminary positions of the columns and beams. So definitely at the end, when we are doing the final design, we are going to change the positions of the beams and columns without affecting the architectural design as per the client's requirement. So now, as a continuation, in this video you can see here I have prepared the complete positions of the beams and columns of the ground floor. And here I would like to make a small change, that here we have 4 cantilever beams. Okay, so as per the architectural plan, so the cantilever beam starts from here to here because this is our boundary line, right? This is our boundary line. So therefore this is my cantilever beam, and next from here to here is my cantilever beam. Then here again from here to here cantilever beam. Then again from here to here cantilever beam. So these are the 4 cantilever beam. Okay, yes, so I'm going to match now. Here, 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 right? So this will be my exact the positions of the beams and columns of the ground floor. Now if you see the plan, so there are small changes with respect to the ground floor as well as with respect to the first floor. So therefore whenever we have a small changes, so better, my suggestion, so better we have to draw another layout of the beam for the first floor. Definitely the positions of the columns will not change, but the positions of the beams will change. Therefore I will just draw the one more line diagram representing the positions of the beams and columns of the first floor. Okay, what I'll do, I'll just I'll just move this entire ground floor this to little bit this side. Okay, yeah, I'll just move. Yeah, now in the same manner what I will do, I just wanted that of the first floor, so therefore what I will do, I'll just make a copy of this. Okay, I'll just make a copy of this, then I'll draw one more line here. Okay, yes, so now this will be my, instead of ground floor, so that becomes the first floor. Okay, yes, so that will be your first floor. Yes, now if you see here students, so with respect to the ground and first floor till here there is no changes. Okay, so till here there is no change at all. So therefore what I can do, till here I can keep all my beams as it is till here. I'm supposed to remove only these beams which is present after that. Okay, which is present after that, I'm supposed to remove these beams. So till here no changes are available. Okay, I can easily remove these beams without any problem. I can remove these beams. Okay, this also I can remove. Right, now after this, if I start seeing, if I start comparing, you can see here. So definitely, yes, so if you see here, definitely I need this complete beam here. Okay, I need this complete beam. This complete beam I'm supposed to draw here also. Okay, this still end here. Therefore what I will do, I'll just draw that line, that is from here to here, then here to here, then here to here. Okay, so that entire thing I have drawn. Then after that, if you see again here, okay, so yes, so that is, yes, so from here to till here. Okay, I need this, so it means I am supposed to split this beam. Okay, yes, so otherwise what I can do, what they have done, you can see here, this beam already anyhow it will be there, so just they made a partition. Okay, so what is this distance? So this distance is from here to here. Therefore what they have done, we cannot remove this beam completely. Instead of that, you can see here, so they made this one. Right, instead of this, what they have done is, anyhow from here to here, this definitely it will be there. Okay, then after that, from here I am supposed to join to this beam, then again from here I am supposed to join here, then I am supposed to join here. So like this they have done. Okay, like this they have done, this will be a shop. Okay, like this they have done, this will be a shop. Now definitely no change here, so this will be there for the staircase. So now you have one more shop here. Right, so it means I'm supposed to have one more shop here. You can check here, this shop. Right, I'm showing this shop here, that is from here to here. Okay, then here to here, here to here, here to here. Right, and definitely this cantilever projection will also be there. This one, this one, like this. Right, so definitely this will be for the staircase, and you can see it here, you can see here, definitely this beam we cannot remove, that is this one, so this will be continued. That means this beam definitely it will be there. You can see here, this beam definitely it will be there. Therefore what I have done, I have connected from this column to this column. Right, so therefore this becomes the plan of the first floor. Okay, this becomes the plan of the first floor. Right, so you can see now whatever these two plans I have shown you here, students, whatever these two plans I have shown you here, so these plans are called as roof beams, or whatever the beams I have shown here, so these beams we call them as roof beams. To be frank, we have two types of beams. So the first type of beam we call it as the roof beams. Another type of beam we call that as the plinth beam. Right. So first type of beam we call it as roof beams. The second type of beam we call it as the plinth beams. So before we do any design, we should be very thoroughly understand what is the difference between the roof beam and the plinth beam. As the name itself indicates, the roof beams are the beams which are provided at the slab level. Then what do you mean by this plinth beam? See, plinth beams are the beams which are provided at the ground level. Okay, just for the sake of understanding, I'll just show you one diagram here. So let us assume that this is my ground level. Okay, let us assume this is my ground level. Now definitely below the ground level, you will be having some footing here. Okay, so no doubt you will be having some footing here. So like this. Okay, you will be having some footing, right? So randomly I'm just drawing them. Okay, so randomly I'm just drawing just for the sake of understanding. Okay, so let us assume like this, below that you have a footing. Now when it comes to the ground level, students, at the ground level we are going to provide some beam, what we call it as plinth beam. Okay, we are going to provide that beam, what we call it as plinth beam. Okay, the reason why we are supposed to provide the plinth beam is it is mainly for the stability purpose. The first reason that you are going to provide is the stability purpose. Like this we are going to provide the beam. Okay, like this we are going to provide a beam, right? For every, when you look from the top, it looks like a normal beam. Okay, what we call it as a plinth beam. So the main reason that you can see here, this is what we call it as the plinth beam. Normal beam only, but here the beam will be resting on the ground. Okay, the beam will be resting on the ground. The beam will be resting on ground. The difference between the roof beam and the plinth beam is the roof beams will be resting or it will be supported on the columns, whereas the plinth beams, they will be resting or supported on the ground. Then you may have the question, then what is the necessity of providing the plinth beam when we are resting on the ground? The main reason is in order to provide the stability to the columns. Okay, especially I have come across the many project students, many clients, they have a misconception that the engineers are wasting the money on providing the plinth beams, but actually it is no. If you are providing the plinth beams, you are making the structure very strong, especially in the earthquake areas or the earthquake prone zones of the India. Without plinth beam, you are not supposed to construct any of the buildings. Okay, you are not supposed to construct any of the buildings. Okay, you are not supposed to construct any of the buildings, because what will happen is we have come across the IS 456-2000 where we calculate the effective length of the columns, right? So when we calculate the effective length of the columns, we know the effective length is calculated between the two supports, that is front support, that is top support, and the bottom support, right? So when we are calculating the effective length of the column between the two supports, as long as the length of the column increases, definitely your effective length also increases. When the effective length of the column increases, then the column becomes more and more slender. So when the column becomes more and more slender and when the load application on that column is heavy, then the columns easily fails by the buckling. Therefore, in order to reduce the effective length of the columns, you are supposed to provide the plinth beam. Then you may have the question how it is possible. I'll just give you one small example. See here students, I have told you that this is my ground level. Now I am providing one column here, okay, and this is my beam, and I am providing my one more column here. Definitely below the column you will be having some length below the ground level, and here you will be having the beam, right? And definitely here will be your footing, okay, here will be your footing, like this. Here will be your footing, no doubt about that. Okay, so this will be your footing, right? Okay, now whenever we calculate the effective length of this column, we definitely calculate effective length from here to here. We definitely calculate effective length from here to here, right? We won't calculate effective length from here to here. That is when we are doing for the ground floor. But when you go for the first floor, no doubt. So we will be calculating here, then like this we will be doing this. So now here in this case, definitely your effective length of the column will be from here to here. Your effective length of the column for the second floor will be from here to here, but your effective length of the column for the ground level will not be from here to here, it will be from here to here. Therefore you can see here in the first floor the length was 27 feet up. Just for the example I am showing, it is 27 feet, whereas when it come to the ground floor it becomes 34 feet. Therefore what will happen if you connect this, okay, if you connect this with the help of a beam like this, if you connect this with the help of a beam like this, then whatever the beam we provide, this we call it as the plinth beam. So that time what happens, the effective length of the columns get splits. That means when I provide the plinth beam, automatically, so from here to here this becomes my effective length, and from here to here this becomes my effective length. Okay, therefore we have reduced the total length of the column at the ground level. So when we reduce the total length of the column at ground level, so the effective length becomes less and the columns becomes, we will try to avoid the slender columns. So thereby we make the structure more and more stiffer by providing the plinth beam. Not only that, anyhow you are supposed to construct the wall here. For that also you can directly start constructing the wall from the plinth beam. So that is the major reason that why we have to provide the plinth beam, is to make the column more stiffer. Okay, so therefore along with your the positions of the beams and columns of the ground floor and the other floor, even we are supposed to have the positions of the plinth beams also. Nothing will change, the positions of the columns will not change. Only the things that you can able to expect that changes in the plinth beam is wherever you have the cantilever projections, that cantilever projections will be removed off, because no need to provide any cantilever projections on the ground. It is required only when you go above the ground level, except that nothing is going to change. Therefore what I can do, I can directly copy this to here, then I can make it as a plinth beam. So because this is my ground floor plan, I have to copy the ground floor plan only, right? I am copying ground floor here to here. So once I copy it, I'll just change it as make it as plinth beam, right? So now what I'll just do, wherever the columns are connected you can keep, so wherever the cantilever projections are there I can directly remove. You can see here, so this entire, these are cantilever projection, so therefore I'm going to remove these two, right? No doubt here also I'm going to remove these three because they are cantilever, right? Then except that this won't, things never changes. Okay, you can remove these partitions, it is not required, we will be connecting only in the ground floor. These partitions whatever is there you can remove them like this. So this will be there, no changes. This also you can remove, no issues. Then again when it comes here, you can see I have removed the cantilever projections. The cantilever projections will come into picture only when you go ground, right? So therefore now I have clearly prepared the positions of the beams and columns of the ground floor, first floor, as well as the plinth beams of the given plan. So once this much is done, the next step is, now with the help of these centerline diagrams as of the positions of the beams and column, I have to start modeling in the software. So in the next video, what I'm going to do is I'm going to start the modeling of this in the software. So while doing that, even I'll explain you how to model in the software also from the beginning of the step. Along with that, we will start modeling. Okay. Thank you, students. We will start the modeling in the next lecture.